In this session, we will discuss about introduction to probability theory. Probability is a numerical measure between 0 and 1 inclusivity of the likelihood or chance of occurring of an uncertain event. Mathematical definition of probability. If a random experiment is repeated a finite number of times, out of which outcomes m are in favor of even A, outcomes n are not favor of even A, and all these possible outcomes are mutually exclusive, collectively exhaustive, and equally likely, then the probability of occurrence of an A is defined as P of A, m divided by m plus n. In weirdly we can say favorable number of cases by total number of cases. Then there are probability terms related to set theory. A union B. That means an event which represents the occurrence of either A or B or both. A intersection B. An event which represents the simultaneous occurrence of A and B. A complement A bar complement of A and represents the no occurrence of A. A bar intersection B bar. Both A and B do not occur. A bar intersection B, even A does not occur and even B occurs. A intersection B bar, even A occurs but even B does not occur. A bar intersection B union A intersection B bar. Exactly one of the two events A and B occurs. Then there are two theorems mainly for probability. One is addition theorem or addition rule. If two events A and B are mutually exclusive, and equiprobable, then the probability of either event A or B or both occurring is equal to the sum of the individual probabilities. In notation, we can say that in notations, probability of A or B is equal to probability of at least one of the events occur is equal to probability of A union B is equal to P of A plus P of B. And for three events, probability of A union B union C is equal to P of A plus P of B plus P of C. So if events A, B, C are mutually exclusive, probability of A union B union C is equal to P of A plus P of B plus P of C. So what is mutually exclusive? If A and B are mutually exclusive, if the happening of any one of them prevents the happening of all others. For example, in the case of throwing a die, the occurring of even number and occurring of odd numbers are mutually exclusive. Another example, in the case of tossing a coin, getting a head and getting a tail are mutually exclusive. So if two events are not mutually exclusive, then probability of A union B is equal to P of A plus P of B minus probability of A intersection B. For three events A, B and C, probability of A union B union C is equal to P of A plus P of B plus P of C minus probability of A intersection B minus probability of B intersection C minus probability of A intersection C plus, it's very important, plus probability of A intersection B intersection C. Then another concept is probability of at least one of the events is equal to 1 minus probability of none of the events. Or symbolically we can write probability of A union B union C is equal to 1 minus P of A bar into P of B bar into P of C bar, where P of A bar is equal to 1 minus P of A, P of B bar is equal to 1 minus P of B, P of C bar is equal to 1 minus P of C. For more clarity, we will consider a simple example along the addition theorem. Of 1000 assembled components, 10 have a working defect and 20 have a structural defect. There is good reason to assume that no component has both defects. What is the probability that a randomly chosen component will have either type of defects? The problem of interest is defects. So we take let A with the event that the component has a working defect and B with the event that the component has a structural defect. Because we are concentrating on two defects, either one of them will create a defect of the product. So let A be the event that component has a working defect and B be the event that the component has a structural defect. Then already we discussed probability of an event is equal to favorable number of cases by total number of cases. Here, 1000 assembled components, 10 have a working defect. So favorable number of cases is 10, total number of cases is 1000. So P of A is equal to 10 by 1000. Similarly, P of B is equal to 20 has a structural effect. So P of B is equal to 20 by 1000. And here there is a good reason to assume that no component has both defects. That is, there is no common defect. In this case, probability of A intersection B is equal to 0. In other words, we say that A and B are mutually exclusive. So if A and B are mutually exclusive, probability of A union B, probability of occurring A or B is equal to P of A plus P of B, that is 10 by 1000 plus 20 by 1000. Taking the LCM, we get 10 plus 20, 30, 30 by 1000, that's equal to 3 by 100, that's equal to 0.03. Another example, the probability that a contractor will get a plumbing contract is 2 by 3 and the probability that he will get an electrical contract is 5 by 9. If the probability that he will get at least one contract is 4 by 5. What is the probability that he will get both the contracts? So here the problem is getting a contract. In this case, let A be the event that the contractor will get a plumbing contract and B be the event that he will get an electrical contract. That is given P of A is equal to 2 by 3, P of B is equal to 5 by 9. They are directly given. And if the probability that he will get at least one contract, we already discussed at least is probability of A union B, that is equal to 4 by 5. Then the question asking is, what is probability of getting both the contract? Already we discussed getting both the formula, that is probability of getting both the contract is probability of A intersection B. For finding probability of A intersection B, we can use the addition theorem of not mutually exclusive events because probability of A intersection B we want to find out. So the probability of A union B is equal to P of A plus P of B minus probability of A intersection B. Here P of A union given, P of A is given, P of B is given, probability of A intersection B is not given. Substituting, it comes to the left hand side, we become positive, it comes to the right hand side, it is negative. So what we get 4 by 5 minus 2 by 3 minus 5 by 9. So answer is equal to 0.43, 0.31. Then what is independent events? The occurrence of an event A does not affect and is not affected by the probability of occurrence of any other event. The event is said to be statistically independent and otherwise it is called dependent events. For example, in the case of a box containing 10 boards, we are taking 2 boards from that box and we are not replacing, it is dependent. If it is replacing, the next when we are taking another 2 boards, these are independent cases. Then rules of multiplication. Probability of occurring A and B together is denoted by, already we discussed probability of A intersection B, and it is equal to probability of A intersection B happen 2 ways. One is probability of B into probability of A given B, and probability of A intersection B is equal to P of A into probability of B given A. So in both cases, probability of A intersection, there are 2 different formulae. The meaning is entirely different. Probability of A given B is the conditional probability of A given that the event B has already occurred. And similarly, probability of B given A is the conditional probability of B given that A has already occurred. So if A and B are independent, probability of A intersection A given B, which means there is no meaning in probability of A given B, which is same as P of A, and probability of B given A, the meaning is that's equal to P of B, because A and B are independent. The happening of B does not affect the happening of A. Here, the happening of A does not affect the happening of B. So, in this case, probability of A given B is equal to P of A, and probability of B given A is equal to P of A. Other cases, probability of A intersection B is equal to P of B into probability of A given B, and P of A into probability of B given A. And what is probability of A given B? There is a formula for that. That is equal to probability of A intersection B by P of B, and probability of B given A is equal to probability of A intersection B by P of A. So if A and B are independent, that is probability of A given B is which is same as P of A, and probability of B given A is equal to P of B. Therefore, multiplication theorem, probability of A intersection B is equal to P of A into P of B. Example, a husband and wife appear for an interview for 2 vacancies in the same post. The probability of husband selection is 1 by 7 and that of wife selection is 1 by 5. What is the probability that, question number 1, both of them will be selected, only one of them will be selected, and none of them will be selected? So in this case, we take one as A and other is B. Okay, here husband is selected, we take it as A be the event and B be the event that wife is selected. Then question number 1, or what we can write, what is P of A is equal to 1 by 5, 1 by 7, and P of B is equal to 1 by 5. So probability that both of them will occur. Already we discussed both of them, probability of A and B, that is equal to P of A into, because A and the selection of husband selection is not dependent on high selection. So in this case, A and B are independent. That is probability of A intersection B, or probability of A and B is equal to P of A into P of B. Just simply multiply, we get the answer. So question number 2, probability that only one of them will be selected. That is husband selected, wife is not selected, or husband is not selected, but wife is selected. That is probability of A and B, and probability of A and A bar and B. That's equal to P of A into P of B bar, or probability of A bar into P of B. Then you can find out P of A bar from P of A, that is 1 minus P of A, and probability of B bar is equal to 1 minus P of B. The last question is probability of none of them will be selected. That is equal to probability of AB the whole bar, which is same as probability of A bar into probability of B bar. Then simply multiplying probability of A bar, you know what's the answer, and probability of B bar you can find out and multiply. Question number 2, a problem in business statistics is given to 5 students A, B, C, D and E. Their chances of solving it are 1 by 2, 1 by 3, 1 by 4, 1 by 5 and 1 by 6 respectively. What is the probability that problem will be solved? In solving problem, all are independent. There is no copying. Or if you are copying somebody's, it is dependent. Here in this case, all are independent. So problem will be solved means 1 minus problem is not solved. That is probability of what student failed to do the problem. So in failing, we denote by A bar. That is 1 minus P of A bar into P of B bar into P of C bar into P of D bar into P of A bar. So P of A bar is equal to 1 minus P of A, P of B bar is equal to 1 minus P of B, and P of C bar 1 minus P of C, P of D bar 1 minus P of D, and P of E bar is 1 minus P of A. Multiplying all these and subtracting, we get answer is equal to 5 by 6. The product is assembled from 3 components X, Y and Z. The probability of these components being defective is 0.01, 0.02 and 0.05 respectively. What is the probability that the assembled products will not be defective? The question is products will not be defective. So we are going to take it as will be defective. Let A, B, C denote the event that the components X, Y and Z being defective. That is given, that is P of A is equal to 0.01, P of B is equal to 0.02 and P of C is equal to 0.05. Then the product will be defective. Either A or B or C will be defective. That is probability of A or B or C. In terms of probability, we use the notation probability of A union B union C. We have a formula that P of A plus P of B plus P of C
minus probability of A intersection B minus probability of B intersection C minus probability of A intersection C plus probability of A intersection B intersection C. Here A, B, C are independent. So we are replacing probability of A intersection B by P of A into P of B, probability of A intersection C by P of A into P of C, probability of B intersection C by P of B into P of C, and probability of A intersection B intersection C can be replaced by P of A into P of B into P of C. Then applying the values, we get 0.01 plus 0.02 plus 0.05 minus 0.01 into 0.02, etc. like that. The answer is 0.0784. Hence, the probability, the required question is probability that the assembled part will not be defective. We got the answer will be defective. Therefore, the probability that the assembled part will not be defective is equal to 1 minus 0.0784, that is equal to 0.0216. So we are applying the trick, probability of A plus probability of A bar is equal to 1. That is, probability of a part will be defective plus probability of the assembled bar will not be defective is equal to 1. So answer is 0.9216.
Another example is for more subjects. That is, a market survey was conducted in 4 cities to find out the preference for brand A soap. The responses are given below. Delhi, Calcutta, Chennai, Mumbai. Yes, that is, they are preferring bars of Delhi 45 people, Calcutta 55 people, Chennai 60 people, Mumbai 50. Not preferring the soap 35, Calcutta 45, Chennai 35, Mumbai 45. That is intersection of this row and this column. No opinion. Delhi there are 5 people, Calcutta 5 people, Chennai 5 people, Mumbai 5 people. Question number is, what is the probability that a consumer selected random preferred brand A? That is, here also we are doing favorable number of cases by total number of cases. For doing this problem, you have to find out the totality. A is 45 plus 55 plus 60 plus 50, that is equal to 210. So A is the event that customer selected random preferred brand A. Then P of A is equal to favorable number of cases 210. The total number of cases is 390. So answer is 210 by 390. The second question is, what is the probability that a consumer preferred brand A and was from Chennai? Here you can see that he is from preferred brand A and he was from Chennai. The cases is 60. He is from Chennai and preferring the brand A is 60. So favorable number of cases is 60 and total number of cases is 390. That is 60 by 390. Third question, what is the probability that a consumer preferred brand A given that he was from Chennai? That is, you have to find out probability of A given C. You have the formula, probability of A intersection C by P of C, probability of A intersection C, that is preferring the brand A and he is from Chennai is 60, that is 60 by 390 divided by 100. He is from Chennai, that is equal to total number of births is 100, favorable number is 100, total number of cases, that is 100 by 390. Striking 390 and 3, we get answer is 60 by 100. Then last question, given that a consumer preferred brand A, what is the probability that he was from Bombay? The preference is coming downwards, so probability of is from M is the event that the customer is from Bombay and preference is given. So first of all, company is preference, that is probability of M given A is equal to probability of A intersection A, M intersection A by P of A, that is 50 by 390 divided by 210 by 390, answer is 50 by 210. Thank you.